You're walking home and a stranger stops you. He says, "Invisible dragons live in my garage." Curious, you go with him. You look. Nothing. He smiles. "Ah, but it's invisible." Silent. Untouchable. You can't prove me wrong. Now think about it. Could you really prove him wrong? If someone makes a statement that can never be proven wrong, is that enough to take it seriously as potential knowledge? This question was at the heart of a philosophical battle that shaped modern science. The logical positivists of the 1920s declared, a statement is meaningful only if it can be verified by observation. Karl Popper disagreed. He argued, the true mark of science isn't what you can verify, but what you can falsify. Verification versus falsification. Two rival filters for separating science from nonsense. Vienna, the 1920s. Coffeehouses buzzing with debate. The Vienna Circle, aka the Logical Positivists, wanted a flawless science. Precise, logical, undeniable. Their rule was simple. If a claim cannot be confirmed by experience, it is meaningless. They split statements into two camps. Some were tautologies, true by definition, like all bachelors are unmarried, or it will either rain or not rain tomorrow. Perfectly logical, but empty of real-world content. Others had to be verifiable by observation. The table is red. That could be meaningful. Everything else? They threw into the bin of nonsense. They leaned on induction. Build general laws by stacking up specific observations. See enough confirming cases and you secure truth. For them, science was meant to be a fortress of verification, standing against doubt. At least, that was the dream. Karl Popper saw the crack in that fortress. Verification never ends. 1,000 white swans don't prove the next one won't be black. So he flipped the method. Science, he argued, isn't built on confirmations. It advances through conjectures and refutations. A good theory is not the one that piles up evidence. It is the one that makes falsifiable, bold predictions and risks being wrong. Theories earn their place only if they survive repeated attempts to kill them. Astrology? Too vague to be disproven, useless. Einstein's relativity? It staked everything on the 1919 eclipse, which was the attempt to falsify it. If the starlight had not bent, Einstein's theory would have collapsed overnight. That risk made it scientific. Popper turned science from induction to deduction. If my theory is true, then this must follow. If the prediction fails, the theory falls. Here the contrast is sharp. The positivists believed truth comes from stacking verifications. Popper believed progress comes from risking refutations. The positivists sought certainty. Popper embraced uncertainty as the very engine of discovery. Picture it this way. The positivists are architects, building a fortress of confirmations stone by stone. Popper is an engineer throwing his bridge into the storm to see if it collapses. One seeks safety, the other finds truth only in trial by fire. This clash is not just history, it shapes reality today. In pseudoscience, crystals heal you, you can't disprove it. Unfalsifiable. In artificial intelligence, oceans of inductive data versus stress testing models by failure. In climate science, theories don't live by a single confirming fact, but by risky predictions that could have failed, yet didn't. The dream of verification never fully died, but Popper's demand for falsifiability became the compass by which science steers. So, next time someone insists they've got an invisible dragon, tell them, I know it's not true because I have a third undetectable eye that detects invisible dragons. They can't prove you wrong, and that's the point. Verification versus falsification. Positivists versus Popper. One asks, can it be confirmed? The other, can it survive being tested by fire? Certainty comforts us, but only risk uncovers the truth. Thanks for watching.